In this video, we're going to be talking about how to find the axis of symmetry and the vertex of a quadratic function. And we're also going to talk about what the vertex of a quadratic function tells us. Then we're going to do an application problem. So let's start off with our axis of symmetry and our vertex. Well, it really comes down to which form is your equation in. So if it's in standard form, where it uses our h and our k, we're going to look at the h and the k. Now, the h is going to tell us what the axis of symmetry is. Okay, so our h is our axis of symmetry. To get the vertex, it's just our h comma k. So it's pretty easy when it's in standard form. When it's in general form, there's a little bit more work to it. So in general form, that's where we have the ax squared plus bx plus c. So here, our axis of symmetry is the equation x equals negative b divided by 2a. To get our vertex, we need to plug that value into our equation, and that's going to give us the y value. And then our vertex will be the axis of symmetry, and then that y value answer. Why is the vertex important? What does it tell us? Well, it tells us the maximum value of our function, and it also tells us the minimum value. So it's either going to be a maximum or a minimum value depending on if the graph opens up or if the graph opens down. Let's do an example. So here we're going to talk about a baseball. So the path of a baseball is given by the function f of x equals negative 0.0032 x squared plus x plus 3, where f of x is going to be the height of the ball in feet, and x is going to be the horizontal distance from home plate in feet. And we want to know what is the maximum height reached by a baseball. Because if we think about it, right, if we're going to hit that ball's going to go up, right, and then come back down. So how high does that go? So if we look at our equation, we see that it gave us the equation in general form. So because it gave it to us in general form, we're going to need to find our axis of symmetry first before we're able to find our maximum value. So remember that in general form, we have our ax squared plus bx plus c. So with our equation, we are then going to have an a value of negative 0.0032. We'll have a b value of 1 and a c value of 3. Now our axis of symmetry, I'm going to abbreviate that as AOS, is the equation x equals negative b over 2a. So we're going to go ahead and we're going to find that. So our axis of symmetry is going to be x equals our negative b, so negative 1 over 2 times our a value. All right, so we took our b. Let's do this. Took our b. There, that color helps it a little bit. So what we're going to do now is we're going to use our calculators. So pull out your calculator, clear your screen, and we're going to go ahead and we're going to enter in that fraction of negative 1 divided by 2 times negative 0.0032. When we plug that in, that's going to give us an x value that is 156.25 feet. Right now, that's the distance from home plate, right? So when the ball is 156.25 feet from home plate, it will reach a maximum height of, and that's what we still need to find. We need to take this value right here and we need to plug that in to our x's so we can see what our maximum height is. So that's what we're going to do next. So we're going to take our equation, so negative 0.0032, and we're going to plug in the 156.25 squared plus 156.25 plus 3. So again, we took out the x's and we replaced it with our x value that we got. Now we're going to plug that into our calculator, and that's going to give us our height. So we're going to take negative 0.0032, multiply that by 156.25, square that, plus 156.25 plus 3. And that's going to give us a value of 81.125 feet. And since we're talking about the height of a baseball, we're going to go ahead and we're just going to round this to 81 feet. So it has a maximum height of 81 feet. And that's going to be our answer.